Hello everyone, my name is Oisul and today I'm going to be talking about class 9 to 10's chemistry books chapter 5, which is entitled as Chemical Bonds. Have you ever wondered why water always stays as H2O or why table salt is not always like NaCl or anything else? Why don't atoms just exist alone? Well, the answer basically lies in chemical bonds. And today we will cover through the whole chapter basically, which will cover and answer the questions. So first of all, what is a chemical bond? A chemical bond is the attractive force that holds two or more atoms together to form a stable molecule or compound. You can think of it like friendship, I suppose. One person alone might not be as stable, but together they become stronger. Similarly, atoms bond to become more stable. So, yeah. But why do atoms even form bonds? That's because they naturally just want to become stable. Most atoms become stable by completing their outermost electron shell, which is called the valence shell. Many atoms try to achieve the electronic configuration of the nearest noble gas because noble gases are already very stable. So what are valence electrons? Valence electrons are the electrons present in the outermost shell of an atom. These are the only electrons that participate in chemical bonding. For example, sodium has one valence electron, oxygen has six, chlorine has seven. So the number of valence electrons determines how an atom will bond. So yeah. There are some types of chemical bonds, and so what are the major types? So the major three types of chemical bond are called ionic bonds, covalent bonds, and coordinate bonds. So what is an ionic bond? An ionic bond forms when one atom completely transfers electrons to another atom. One atom loses electron and becomes a positive ion or a cation, and the other gains electrons and becomes a negative ion or called an anion. The electrostatic attraction between these opposite charges forms an ionic bond. For example, it can be like sodium chloride NaCl, which is table salt. Sodium has one valence electron. It donates that one electron to chlorine. Then sodium becomes Na positive ion, where chlorine becomes Cl negative ion. The attraction between Na positive ion and Cl negative ion creates the ionic bond basically. What are the properties of ionic compounds? Uh, they usually have high melting and boiling points. They are hard and brittle, conduct electricity in molten or aqueous state, usually dissolve in water, and also they can exist in crystal solids. Most common examples include NaCl, MgO, and CaCl2. So another one of the chemical bonds is called a covalent bond. What's a covalent bond, you may ask? Instead of transferring electrons, atoms share electrons. This sharing creates a covalent bond. It usually occurs between nonmetals. Some examples can be hydrogen. Each hydrogen has one electron. They share one pair of electrons. Both now behave like helium and become stable because helium has two electrons. And then there's like oxygen as well. Each oxygen needs two electrons. They share two pairs of electrons. This forms a double covalent bond. And another one is nitrogen. This is the same case as well, where they need like three pairs. Which is a triple covalent bond, by the way. So that's that. These things are called single, double, and triple bonds depending on what it is, what atom you're like asking about. So yeah. So what are the properties of covalent bonds? They have like low melting and boiling points. Usually do not conduct electricity. Are often gases or liquids. Many are insoluble in water but dissolve in organic solvents. So yeah, examples are like water, carbon dioxide, etc. So yeah, another one was coordinate or dative bond. This is a special type of covalent bond basically. Both shared electrons come from only one atom, the other atom only accepts the electron pair. So yeah, examples are like H3O or positive ion or NH4 positive ion. You get the idea. So yeah. So there's a thing called a Lewis dot structure. What is that? So a Lewis dot structure is a simple way of showing only the valence electrons of atoms. Dots represents electrons. By drawing dots, we can easily understand how atoms share or transfer electrons while forming bonds. This is one of the most important diagram topics in the chapter. So yeah, it's an important thing to know. So there's also a thing like discussed in the chapter which is called the octet and duet rule. So what is the octet rule? This rule basically says that atoms try to gain, lose, or share electrons until they have 8 electrons in their outermost shell. This makes them more stable like noble gases, which they like naturally want to become, as I discussed before. There are some exceptions, but for like this chapter, the octet rule mostly explains like about bonding. So yeah. So another one was the duet rule. What is that? Let's say like hydrogen and helium only need two electrons in their outer shell. So hydrogen follows the duet rule instead of the octet rule. So that's that. So yeah. So how can we let's say like quickly identify ionic and covalent compounds? A simple trick is that metal plus non-metal usually results to usually ionic bond, and non-metal plus non-metal usually is like covalent bond. This shortcut can save you much time wherever you are in need of. So yeah. So which bonding stronger? So it depends basically. Generally, triple covalent bond is greater than double covalent bond, which is also greater than single covalent bond. Ionic bonds are also very strong due to electrostatic attraction, especially in crystal lattices. So yeah. Well, that was the basically the whole chapter. I basically talked about chapter 5, and yeah, thank you for listening to me. And that was chemistry books chapter 5, chemical bonds. So yeah, thank you for listening to me, and that's all for today.